Hey everybody, thanks for joining us today for this discussion around what's new for DynamoDB. My name is Rick Houlihan. I'm a Senior Practice Manager for NoSQL for AWS Professional Services. We're going to be talking today about some of the exciting new features that we've had released for DynamoDB not only recently, but in the last year. We're going through a lot of new stuff. Should be a great discussion. For those of you who are a little unfamiliar with what DynamoDB is or just trying to figure out, what is this NoSQL database service that I hear so much about, Amazon DynamoDB really is a highly scalable, very fast and consistent, fully managed database service that's built for businesses to run at any scale. Literally, we have auto-scaling that functions to hundreds of terabytes of data. We have tables that serve millions of requests per second, and we have hundreds of thousands of customers that have used this service over the years to deliver many applications which we're all very familiar with. As a matter of fact, most of us are customers or at least users of DynamoDB indirectly just based on the services that we use. As we said, we have over 100,000 customers, including companies like Samsung, Amazon itself, Amazon Retail. If you buy anything from Amazon, which a lot of people do, you're using DynamoDB because we power a lot of the retail services that actually drive the enterprise retail organization of Amazon. Samsung runs the Galaxy Sync service off of DynamoDB. If you're a Samsung Galaxy phone user, your data is probably stored in DynamoDB somewhere, and a variety of other services as well. BMW, Electronic Arts, again, online gamers, lots and lots of services built on DynamoDB. Expedia, Under Armour, many more companies that leverage DynamoDB, over 100,000 commercial users. At Amazon, we have a principle in the company. It's kind of something that we kind of stumbled onto, I guess you'd say, or we we're one of the first people to adopt the DevOps practice of kind of you build it, you run it. And Werner Vogels was a big proponent of this many years ago, and we kind of developed the service-oriented architecture that drives Amazon and Amazon Web Services. But what does that really mean from a developer perspective? And what it comes down to is, as a developer, there's a certain set of skills that we're very familiar with. How to write the code, how to build the applications and whatnot. Maybe we're a little less familiar with some of the other things that go into kind of this DevOps type of mode of operations. Things like database administration or systems engineering. And really what it comes down to is that the developer today is kind of responsible for all of these things. And really what they are is an intersection, right, of all of these skills. And so what is it that all of these, what are all the things that these people do? And when you look at the responsibilities of a DBA and the system engineer, there's a lot of things that go into actually delivering these services. Things like security patching of the operating system of the database, various application layer software, access controls and permissions, audits, encryption of your data, compliance with various regulatory processes and procedures, the durability of your data, right? I mean, we have to worry about the infrastructure itself, rebuilding servers when they fail, managing the backups and the restores. And there's a lot of things that go into maintaining the configuration for the availability, the performance, the durability, security, and the scalability of your application that all of your DBAs and your systems engineers are responsible for. And not only that, but they have to do all of this with near zero downtime, or with almost no downtime in some cases, right? So it's a big chore. So what we do with DynamoDB is we focus on the ops, so that you can focus on the dev part of the ops, right? So of the DevOps discipline, and that's really what it comes down to. And that's the message around Dynamo, is that you don't want to be focused on building out infrastructure and developing IT expertise. What you want to do is focus on the development skills that required for building your applications and delivering your services to your customers. So let us focus on all that other stuff. So with that in mind, we're going to talk about some of the great new features that we have delivered over the last year with DynamoDB. And we're going to start off with one of the biggest ones that has been on the top of our list for many of our customers is global replication of data. Right. So DynamoDB today now is the first fully managed multi-master, multi-region database with the release of the Global Tables feature. We're going to talk a little bit about some of this, but let's actually just walk into a demo where I'll actually just show you a little bit about how easy it is to actually build your global tables with DynamoDB. So in this example I have, I'm logged into a DynamoDB region. It's in Oregon. This is our US West 2 region. I have a table that I've configured here before the demo, so we can take a look at. This is a global demo table that I have. If we look at the Global Tables tab, we can see that there currently are no global tables. And what I'm going to do is go ahead and configure a table in our Ireland region, so you can see how easy it is to do this. So the first thing we need to do when we set up a global table is actually enable streams, because that's the service that we use to actually replicate data, right? Streams is the running changelog for a DynamoDB table. All the write operations against a DynamoDB table will be replicated to the DynamoDB streams, where they can be read and processed by other for other activities. One of the activities that we leverage streams for is global tables. So the first thing we'll do is we're going to enable streams on the global demo 1 table. So this gives us the ability now to replicate that data. Any data that changes on the global demo 1 table will be replicated to the stream. So at this point now, I can simply just add a new region. And currently we support 5 regions: US West 2, which is Oregon, Frankfurt, Ireland, North Virginia, and Ohio. Other regions will be coming shortly. Eventually, obviously, we'll support all regions. But currently, we are going to go ahead and select EU West, which is our Ireland region. We're going to go ahead and continue to create our global table there. So there's 2 things happen. The first thing that goes on is we're going to create that replica table. And what we're doing is we're going to read all the configuration of our current table in US West 2, and we're going to apply all those settings to that table in EU West. So I should have a duplicate of this table. Global Demo 1 should now exist in 2 regions, both US West 2, which is Oregon, as well as EU West, which is Ireland. And so I can actually go to that table, and we can take a look, and you can see on the console I'm now in Ireland. And what happened was that table actually replicated the full configuration to the EU West region. Okay, so that was very, very straightforward, very easy process. And what we're going to do now is we're just going to go ahead and fire up a client and start writing some data into that table. So it's a pretty simple client. We're just going to log into a EC2 instance that I have set up in our Oregon region. You can see I'm just going to go ahead and run a Java utility that I wrote that just starts writing data into, oops, this is the wrong table. I'm going to actually start this up, and I'm going to write that demo, that data into the demo 1 table, and we're going to start inserting data into that table. So we'll come back in a few seconds and take a look at that, but let's go ahead and talk about global tables for a second. So what is global tables? How does this actually work? And it's a couple seconds or so it takes for that replication to occur when writes occur in a source region. For those writes to replicate to external regions, typically you can look at a sub 1 second replication latency. It's a very, what it exists for is low latency reads and writes, right? So I can have a user that maybe hops on a plane in the UK, flies over to the west coast of the United States and gets off the plane. He may have some messaging that's going on, and he can interact with a local database, right, when he gets off the plane to read his messages and post updates, and those updates would then replicate to the remote tables where other users that he's interacting with would again have a low latency experience interacting with the application. So that's one use case. Another great use case for global tables obviously is data replication, right? DR, HA applications, right? I just need to get my data out of a given region in case of a disaster or a failure, and I need to be able to have the ability to stand up new application infrastructure and not lose data. So again, this is the first fully managed, multi-master, multi-region database available for users, and we believe that global tables is going to be a huge feature for many of our customers. As a matter of fact, we have many customers already leveraging the tables or leveraging global tables for their use cases. Let's go back and take a quick look and see where we are now. So we've been running for a while. We've been inserting items. Let's take a look at our table in Ireland, and we can see, actually look at both tables. First, we'll look at our table in Oregon, and we can see the items that we're inserting here, just some test data, not necessarily all that interesting. But if we go over to Ireland, we actually weren't inserting any data in Ireland, but if I look at the items on the Ireland table, you can see all the data that's replicated from those inserts in US West. Now, one of the cool things about this is you actually get that metadata on the table. So you see these 2 last columns represent not only the the region in which this update came from, but the timestamp at which that update occurred. All right, so the default resolution between between the tables, if I were to insert data or update data on two tables at the same time, is that timestamp. And AWS does maintain some clock synchronization across regions, which we will use to try and resolve any types of conflicts which occur during the replication process. All right. So very straightforward process to create those tables, pretty easy overall. Again, very flexible. You can replicate currently today up to 5 regions. We have more regions on the way. So let's talk a little bit about some of the security features that we've added into DynamoDB over the last year or so. And really to start with, the first one is the virtual private clouds, or VPC endpoints, right? So one of the things that we've heard from customers often is, love Dynamo, we love the features, and we love the managed, aspects of the service, but we don't like the fact that you have this public endpoint that we have to talk to. And even though we know that AWS has a very robust security protocols and through roles and permissions that can be assigned through IAM, they just don't like the idea that there's a public endpoint that could potentially be assaulted, for the data that they're accessing on their table. So, to accommodate those customers, we have delivered what we call VPC endpoints. These are basically routing endpoints that are located on your VPC. Very easy to create. They're created on a per VPC basis. So if you have more than one VPC in your configuration, you can create a VPC endpoint for each one of your VPCs. This gives you the ability to access DynamoDB without traversing the public internet. So there is no public endpoint involved. Other clients will not be able to access that VPC endpoint unless they are on your virtual private cloud network. Okay, so once you enable the VPC endpoint for a given service on that VPC, in this case DynamoDB, then all access on that VPC from all endpoints on that VPC will occur through that configured VPC endpoint. So this is a great security feature. It gives you a little bit of a performance boost because there's a hop or two that we're eliminating, but it's really not terribly significant. You may notice it on very large workloads, but on individual requests you probably won't see much of a performance increase. And it's very secure and fast data transfer between the VPC and DynamoDB. Okay, the next thing to talk about is something that is we've been waiting for a long time. A lot of our customers have been looking for this. We've supported encryption in the past through the client-side encryption library, but now DynamoDB has first-class support for encryption through server-side encryption at rest. This is really a great feature that we've recently released for our customers. It allows us to support many workloads that previously had issues around compliance because of encryption at rest, and customers that were not necessarily willing to pay the cost or the overhead of coding the client-side encryption library. So this is really great feature for customers that they can very easily enable when they create the table. It simply just creates a checkbox. You just select encryption at rest. When you create the table, it only works today for new tables. You cannot take an existing table and enable it. However, every new table you can create, very easy to enable. You just select encryption at rest and you can verify it. When you look at the table configuration, it'll tell you right there if server-side encryption is enabled or disabled. And then what it does is it uses envelope encryption, right? AES-256 envelope encryption. This is industry standard encryption for your data. It's fully integrated with KMS. It uses the customer master key for DynamoDB. When you create your first encrypted table, if that master key does not exist in your KMS repository, it will create that for you. This will encrypt both base tables and indexes. Okay, so when you create the base table and you create the base table as encrypted and you create indexes on that table, those indexes will also be encrypted. And it's a transparent process with absolutely minimal performance impact. So you can verify this yourself, set this up against the table. It's encrypted or unencrypted. You should notice a very minimal performance impact between the two with no modification to your application. Again, this is server side. Does not require you to actually integrate this functionality into your application in any way, shape, or form. So very cool feature, something a lot of customers have been waiting for a long time. It's here today. Go take a look. It's enabled in a few of our regions. It's going to be rolling out across all regions over the next couple of months. All right, so performance performance is always something that customers are very, very interested in, and one of the things that we have been able to deliver with DynamoDB over time is very consistent, very low latency performance, at any scale. And so these are some performance graphs from production applications that we can look at, and you see as performance, as the throughput or the capacity that's being delivered for this particular table increases to millions of requests per second. I think it's just a little over 1 million requests per second. You can see the average latency and the difference between the lowest latency response and the highest latency response, and it's only 3 milliseconds, right? And not only that, but it's not like there were a lot of those high latency responses, right? I mean, it's kind of like that one little flyer sitting there that came out of nowhere and threw the high latency response, but that's not even all that high latency. So DynamoDB has been very good at delivering that very consistent, low single millisecond latency response at any scale, and we've got time after time after time, we have use cases where we've delivered that kind of performance. However, many of our customers need better, right? We have a lot of customers in ad space. They're running real-time operational analytics, and every millisecond matters. They're running millions of requests, per second, trying to drive, complex algorithms, and they can't deal with the latency that, DynamoDB has had. They need lower latency than the millisecond. They need sub 1 millisecond. So we have listened to those customers, and we've recently delivered a feature called DAX, DynamoDB Accelerator. Some of you may be familiar with this. This is a fully managed, highly available, fully integrated front-end cache for DynamoDB. It handles all the software management for the cache, all the cache synchronization. This is not a side cache. This is a first-class, component that's integrated into the system. So what you'll do is you'll deploy a DAX cluster on your VPC. This is actually a hardware, cluster. It's a cluster of endpoints that can scale up to 10 nodes. So you can support very, very, very high read transaction loads, and it will integrate with the DynamoDB table. So it fronts the table. And what you do is you install a custom driver, a new driver. It's a Java SDK. I believe Java SDK only today. And when you install the Java SDK for DAX, you will point your clients to the DAX head node cluster, in which case all the requests are going to go to DAX. If the DAX nodes have cached the items that you're looking for, the query that you're looking for, query result set, then it will serve up that result set from memory. If not, it will turn to the table and it will read that data from the table. So when you write back to the DAX head node, it will invalidate those items in cache and send those write requests off to the table as well. So a couple advantages from DAX. Obviously, that sub 1 millisecond response time. Once those items have been read and they're in cache, then every subsequent read is not only going to be sub 1 millisecond, but it's going to be free, right? You pay for the DAX cluster, you don't pay for the reads against DAX. So you're taking a lot of the read capacity that you had provisioned on the table, you're going to be able to deprovision because DAX is going to be handling those reads. But DAX is also a fully managed environment, right? So we've been able to do some things with the driver. So even cold reads to DAX are a little faster. So let's look at that. Let's look at how this actually works when we start looking at the actual DAX node or load. So I'm going to dial into a node here. This node's up in Virginia. We have a table in Virginia. It's got 1 million events on the table, and we're going to go ahead and scan that table through what we call a right-sharded GSI. All right, so we're reading this table. Again, 1 million events on the table. I've got a partition GSI, logically partitioned across 10 logical values, and I'm running a scatter gather across all 10 of those partitions, and I'm reading 1 million events. And the first thing we're going to do is going to hit it from the public endpoint, right? So that's what we're doing right now. This process is sitting there. It's reading from that public endpoint. It's going to take a few more seconds here, and this is about the slowest read we can get, right? So we're reading 1 million events. That's actually not that slow. We read those events in 22 to 24 seconds across 10 threads. Each one of those threads read about 100,000 nodes. And now what we're doing is we're warming the DAX cache. We're making the exact same read, but this time we redirected those reads to our DAX head node. And it's the first time we read the DAX head node, it actually took us about 10 seconds. So you can actually see a pretty significant difference here, right? The first read against the public endpoint to scan for 100,000 or 1 million events took about 22 to 24 seconds across 10 threads. That exact same workload running against DAX took about 10 to 11 seconds, 10 to 12 seconds on the cold read. So the fact that DAX is a fully managed environment gives us the ability to kind of do some things with the driver that allow us to optimize those reads. And you can see the difference, in the default settings for this SDK driver, 311 total pages read. The default settings against the DAX driver, we read 1,005 pages. So we're doing some things with pagination. We're doing some things with the way that we have the driver optimized and memory space on those nodes optimized to support these high performance reads that we wouldn't necessarily be able to do with the SDK because we can't just take 100% of the processing space of the box. So that gives us some advantage there, and we can actually leverage that by giving you better performance even on cold reads. But those warm reads, that's the really impressive thing, right? 22 to 24 seconds, right, to read that against the default public endpoint. That same query against a warmed DAX cache, less than 5 seconds on average, right? So almost 5 times faster, to read, from a warmed cache node, right? So really impressive performance that we're getting out of the system these days that we have once you have that DAX cluster deployed up in front of it. DAX head nodes are authorized to access the table. So what you're going to do is you're going to authorize your nodes to access the DAX head nodes, and then you're going to authorize the DAX head nodes to access the tables, right? So the IAM permissions that you read Dynamo with are actually defined, for the DAX cluster itself. So if you need different roles and access permissions for the table, you probably want to bring up different clusters depending on which application layer processes are accessing. Okay, so again, really big performance boost. That in-memory performance and throughput is more than an order of magnitude faster. It's literally, we just saw it 5 times faster in this example. The latency dropping from 5 to 6 milliseconds to 200 microseconds, right? Amazing performance boost when you look at the DAX in front of the table. All right, moving on, let's talk about some of the durability features that we have today that we put out there. The biggest one to really look at is the DynamoDB backup and restore. Today we are the only cloud database to provide on-demand and continuous backups. This is a storage level snapshot. It's an instantaneous process. It does not take any capacity off the table. To date, our only solution for backups has really been kind of a table dump. This is the way many NoSQL databases actually do their backups. What we've got today now is a fully managed snapshot backup and restore process, and we'll go take a look at how easy it is to do that right now. So in this example, what I've got is I'm going to look at our Virginia region and the table that we were just reading all those events out of. We can see it's a relatively small table, 320 megabytes. I think I probably got a backup or two. Yeah, we've got one backup that we already did here, but let's go ahead and do another backup, see how easy this is. I'm doing this from the console, but you can do this programmatically. You can do this from the command line, pretty much however you want to do it, scripted or from your application. But let's call this just backup test 1. And this is going to be really fast. I mean, it's only 320 megabytes, but it really doesn't even matter if it's a terabyte because it's going to be just as fast. Oh, what do you know? I'm done, right? And I can actually look at it and say, okay, I just backed up 318 megabytes in less than a second. Well, and again, we did that because it's a storage level snapshot, so we don't have to actually impact the table performance. We don't have to read data off of the table. It's just an instantaneous operation. If I have 1,000 partitions, it may take a second or so. It's not going to take minutes to do this, and it's certainly not going to impact your table performance at all. Now, if I look at the table right now, we won't see any metrics or performance, whatnot, but I mean, if I had a steady write load going against here, when I hit that backup, it's not going to cause a hiccup at all. So this is, again, storage level backup, snapshot, backup, restore functionality in DynamoDB. Back up hundreds of terabytes instantly with no performance impact, and this is very powerful feature that's been sorely lacking in the platform. Again, now available for customers. Please go use it, check it out. It's a pretty powerful solution. All right. Let's talk a little bit about some of the scalability and the adaptive, kind of capacity features of Dynamo. Some of these things are things that you're going to be able to take advantage of, and you'll be able to configure yourselves in the console. And some of these things we'll talk about are actually just kind of enabled for you on the control plane. And it's important, though, for you to understand, how we've improved, DynamoDB over the last year, and some of the things that are happening behind the scenes that you might not even be noticing that you're taking advantage of. And the first thing is about capacity planning, right? And we know it's hard, right? It's a really hard thing to do, but it's also very, very important, because if you don't get it right, you're either wasting money or you're making your customers angry, right? So the best thing to be able to have is a system that's elastic and flexible enough to meet the capacity requirements of your workloads, at any time, in any way. And that's what we strive to do with DynamoDB. So some of the things that we're actually doing lately to get that right is what we call adaptive capacity. And this is why, one of these things we call it the backplane, the control plane features. When you get it right, nobody knows anything about it. It just works. But when you get it wrong, everybody knows. And to date, there's been something wrong with Dynamo. It's been called, partition dilution, right? So we've gotten really, to the point with adaptive capacity, we've mitigated that problem. And I'll explain how this works. So, today what we have, is a system where the number of partitions that we have on the table kind of define how much throughput and storage that your table can support, right? So in this particular example, if I have a table that's provisioned with 500 WCUs, 1500 RCUs initially, that's going to give me one server partition, one storage node partition, because the storage partition is capable of delivering up to 1000 WCUs or 3000 RCUs. Okay. Now every table in DynamoDB gets what we call 5 minutes of unused capacity, and what we call the burst bucket, right? So the burst bucket can be drained as fast as the partitions that you have on the table can drain it. In this particular case, I have one partition, and that means that I can drain my 5 minutes of unused burst capacity at a rate of 1000 WCU or 3000 RCU. So the way the math works, right, if I had not been using this table at all for 5 minutes, I would have a burst bucket that's 150,000 WCUs and 450,000 RCUs. I would be able to peak out at 1K WCUs or 3K RCUs. So including my provision capacity, that allows me to burst up to 5 minutes at twice my provision throughput, right, in either WCU or RCU, okay? Not at the same time, but one or the other. So you see how that works, right? 5 minutes of unused capacity, there's a certain amount of provision capacity, back out that provision capacity, and that's how much burst I can drain. So with one partition, I can go up to 5 minutes, right, in either way. Now, let's say I go ahead and I grow this table and I add another partition, right? I go beyond 10 gigabytes, we split the table, we get a second partition. Now what's going to happen is that provisioned capacity is going to get split up and allocated across those two partitions, and that's going to be called what we call a soft limit. It used to be what we call a hard limit, but today it's a soft limit. So when you start going past that soft limit, we're going to start looking at this burst bucket, and we're going to start draining that burst bucket. Now what's interesting here is because I have two partitions, I can actually sustain throughput that's twice as much. Right? So now I can drain my burst bucket at 2K WCU or 6K RCUs, right? So that means that 150K burst bucket, I can drain that guy a lot faster, right? I can drain him in only 100 seconds because I can burst a lot higher. So you're getting the idea here. If your burst on-demand throughput is high, you want a large number of partitions to be able to support it, okay? Let's go ahead and roll the math forward again. Let's go out to 3 partitions. Same thing. Now all of a sudden I'm splitting the partition throughput out a little bit more. I'm increasing my burst capacity. I'm draining my burst bucket faster, right? Now I can only go up to a minute, right? Last chart was 100 seconds. Now it's 1 minute, right? At 3K WCU or 9K RCU, so on and so forth till we get to our 4th partition, right? And it keeps on going and going and going. Now we're going to increase the burst capacity. We're going to decrease the amount of sustained throughput we can process at burst as a result. Now what happens if I run out of burst, right? And this has been where people have gotten into a lot of trouble in the past, right? Things are all fine and dandy until all of a sudden the burst bucket is empty and those per partition throughput limits become really, really bad stop signs, right? And we start throttling people. Well, today, it doesn't quite work that way anymore. Today we've implemented a new solution we call adaptive capacity, and what's really neat about this is if you look at the chart here, this is a table that was kind of cruising along, and eventually they got to the point where they were using that burst capacity, right before that little gap, okay?
When that gap happened, they exceeded their soft limits, and we started throttling the table. And the control plane immediately noticed that and went, oh, but that's not fair because this table actually still has provision throughput in his allocation. So what we'll do now is we'll allow those hot partitions, instead of throttling them, we will allow them to borrow the unused capacity of their peers. And so this is kind of how that looks, right? What's going to happen on the backplane is you're going to go to a certain point, the system's going to notice you've exceeded your soft limits, you're out of your burst capacity, your table is throttling on a per partition basis, but you're below your provision throughput levels. He will release those controls and it'll start to allow those partitions to burst up to their peak capacity as long as you still have partition throughput left, provision throughput left. So this is what that looks like. You'll see a very short duration of throttling. The adaptive capacity ratios will be adjusted, and the table will then be able to continue to deliver its workload as long as you're not exceeding the per partition throughput limits of 1,000 WCU or 3,000 RCU. Those are still hard limits, but if you're below that and you're below your table capacity, you're going to be able to continue going without errors. So what does this mean? What does this look like? This is what that performance chart will tell you. If we're looking at the per partition throughput in a given workload, we might be seeing that maybe the per partition soft limits are about 25 writes per partition. We get into a situation where we have one partition that's delivering a much higher number of writes. Eventually he runs out of burst. He gets to that sustained throttling window right there in the middle, and he will say, then we will enable the adaptive throughput, and the boost will kick in. Right, so now he's borrowing, once you get out of that sustained throttling window, he's borrowing capacity from his other partitions on the table. The other three nodes on this table are lending that fourth node capacity so that he can meet the demand for his workload. Now, just to give you an example, more than 2,800 Amazon tables and indexes on Prime Day did not throttle because of this adaptive throughput. So we have thousands and thousands of tables across our customer base that are leveraging this adaptive throughput feature without even knowing it today. So before, it would have been a support call. Why is my table throttling? Customer's confused. We didn't understand why this is happening. We were just fine. All of a sudden, our table split and our per partition throughputs were cut in half, and the workload that was just fine yesterday is throttling. These things don't happen anymore. So we have a much, much better system for our customers to leverage with this adaptive throughput. The other thing we've done now with as far as scaling goes is time to live. Time to live is a great feature. A lot of customers don't necessarily need their data forever, right? Especially in many workloads after 30 days, 60 days, 90 days, or some period of time, the data on that table is actually kind of useless, or it's irrelevant, or it's not accessed very much anymore. So what we would like to do is remove that data and archive it, or maybe just delete it. So one of the best ways to do that with DynamoDB today is just to enable what we call time to live. When you insert the items on the table, you can define a TTL attribute and insert a timestamp into that attribute. That timestamp is a Linux epoch in seconds, and it defines the time at which you want the item to be removed from the table. At some point after that expiration occurs, there's going to be a process that trolls the table using unused IOPS, and he will find the item and delete it. It's not going to happen right away, but it should happen within a couple hours of the TTL expiration. All right, so that's a great way to keep those tables clean. We've had many tables or customers leverage TTL to clean up existing tables and and save terabytes of storage cost. Right, as a matter of fact, I think CloudWatch is one of the biggest beneficiaries of TTL, terabytes of data that they've been able to eliminate from the system, literally millions of dollars of OpEx that has been carved out of the CloudWatch ecosystem just by enabling TTL on their tables. Auto scaling. This is another really huge feature. We've had this available in the I guess you'd say the ecosystem for DynamoDB for some time through a third-party library called Dynamic DynamoDB. The service team has recently taken all of those features and rolled them in to the product and the service as first-class features supported by the service. So you can actually enable auto-scaling when you define the table. You can set the floor, you can set the ceiling, you can set the target consumption percentage. So if you set that percentage very low, you'll be more susceptible to spikes spikes in your workload. If you set it very high, you'll be, looking for slow, steady, increased workloads. But there's, the bottom line here is we want to save you some cost by, allowing you to provision just in time, so to speak, right? As the load demands, the auto-scaling library will start to adjust the capacity of the system upwards to accommodate increase in load. And to kind of get a look at how this kind of operates, we can take a look at the tables that we created earlier, right? I created those global tables, and those global tables have been running for some time now, and we started off at a pretty low capacity, right? So if we go back and we take a look at our capacity now, we can actually see what kind of scaling activities we've had on this table, and we've had a few. We're actually in the middle of one right now, apparently, but there's a if we look at the metrics, we can see that as that load is increased over time, you can see the auto-scaling going and the burst bucket draining and then the auto-scaling firing and repeatedly over and over again. And what's really interesting about this is we've not only auto-scaled the table here in Oregon, but if I go over to the table in Ireland, right, which was all part of our global table, that's been mirroring the performance, right, of our global table in Oregon, because it's been taking all of the writes. So you can see the exact same scale metrics occurring, on the target table, on the source table, and global metrics and global tables, and auto scaling is coordinating all of that across all of our tables, right? So, if we look at the current capacity levels right now, we're started off at 200 WCUs, but again, since the clients have just been pounding and pounding and pounding and taking up more and more capacity, we've had to increase up to 583, and eventually we will probably exceed even that. So pretty neat technology to be able to manage the capacity of multiple tables across multiple regions. I mean, in this particular example right now today, I just set this up in like 2 minutes. We've been replicating data halfway around the world, and we've been managing the scale of those tables dynamically and independently of each other as that replication load scales. So, I mean, this is a very powerful technology that you have available to you, a whole set of them, right, that you have available to be able to deliver these applications. And if you think about the amount of time that it would take to be able to set up that kind of infrastructure yourself, right? Provision that data center, the rack space, get that equipment provisioned, be able to spin this stuff up. I just did this in minutes. There's no way you could do that in that amount of time, in any other environment than a cloud service provider like AWS. It's basically about scaling your throughput when you need it, right? The auto scaling is fully managed, totally automatic. Scale up when you need it, scale down when you don't. It's on by default for all your tables. When you create a brand new table, it's just going to be turned on. You can turn it off if you want. One of the things that we do tell people with auto scaling is if you know that you have a scheduled event, right, like Black Friday, Cyber Monday, or Prime Day for our business, we tell all of our teams, turn the floors up, right? Don't go into a known peak event, provisioned at a low level and expecting auto scaling to react, right? Auto scaling needs a couple of minutes to be able to register the fact that it's got to add more capacity. So if you have like a thundering herd type of workload, then you either want to programmatically increase the capacity on the tables, or you want to go into that scheduled event knowing that you're going to be provisioned at a higher level. Now, auto scaling does support scheduled auto scaling events, so you can actually push these things into the system and say, hey, provision me up at this time, as opposed to wait for the actual load to increase. So that's something to take a look at with scheduled auto scaling. All right, so Amazon DynamoDB, if you look at what we've done in the last year, I mean, it really is amazing. The number of features, time to live, global tables, VPC endpoints, encryption at rest, on-demand backups, auto-scaling, DynamoDB Accelerator. I mean, the list goes on and on and on, and the amount of features, it's just accelerating, right? And it's one of the things I love about being, some in the front of this service and being able to talk to customers about this service is coming at them this year and being able to talk about all the problems we've solved with all of these technologies and all these features that we've delivered. DynamoDB is more ready for prime time than it has ever been. We have over 100,000 customers today, and with this new feature set that's been delivered over the last 12 months, I expect that we'll be doubling that in no time. There are so many people that have been sitting on the sidelines waiting for some of these features, and they're here. Get down there, check it out. There's a lot of great stuff for you to play with. We have single tables serving literally millions of requests per second, trillions of items, terabytes of data. There is no limit to what DynamoDB can do. We have literally single tables with over 100 terabytes in size. Some of the biggest workloads in the world, run on DynamoDB, including some of the biggest services that we have here at Amazon. And one of the things we like to talk about is not just ourselves, we talk about our customers. And so it's always nice to talk about some of the things that our customers are doing with DynamoDB. Probably one of the biggest things to talk about is, some of the migrations, right, that are happening. I mean, NoSQL technology is fantastic. I love it. I've been working with NoSQL technology for almost 7 years now. And it's just been an eye opener to be able to see what this technology has been able to do for customers as far as being able to deliver applications at scale. But it's also expensive, right? It's very, very hard to run, and a lot of customers are finding out as they scale, NoSQL backends like Cassandra, like MongoDB, the cost of running that infrastructure, and it's just not something they want to focus on, right? They want managed services to run this infrastructure for them. They don't want to run it themselves. So you look at Samsung was a perfect example. They moved almost a petabyte of data, from their Cassandra environment to DynamoDB and saved almost 70%. Right, and these are real-world use cases, right? Just the amount of engineering resources that they had dedicated to running a Cassandra cluster, they have now repurposed all of those engineering resources to customer-facing products and services. It's an enormous investment that they had made in infrastructure. It's been freed up to deliver those features to customers. So amazing win for Samsung. Let's talk about patsnap. These guys store online patents. 125 million patents they stored in DynamoDB. 50% cost savings over the MongoDB cluster that they were running. Again, it just comes down to the amount of time and effort that you must invest in maintaining this infrastructure. And some of these quotes are great. I mean, thanks to DynamoDB, providing and updating 125 plus million patents over 100 plus customers requires zero effort. And that's really the message here. You don't want to manage this, right? You don't want to pay, IT systems engineers and DBAs to run, this technology for you. You'd rather have somebody doing it for you. You look at Amazon. We run operations at scale that most companies, might never see, right? We certainly run at a scale that's beyond most businesses today, and you could almost say that we're a forecast of the future of IT operations in enterprise, right? So, one of the things that we ran into not so long ago was, breaking the relational database platform, right? The biggest, the most powerful relational database platforms in the world were incapable of delivering the type of performance that we demanded, right? That we required to run our business. One of the reasons why DynamoDB was invented in the first place. So, we have an ongoing project in the company. Something that I am actually, very, very tightly engaged in is the migration of Oracle from Oracle and other relational database technologies to DynamoDB and NoSQL, and we're seeing an amazing performance increase. Right, workflow processing delays dropped from 1 second to 100 milliseconds. That's on our main customer order workflow. Right, there's a case study that we talked about at reInvent if you want to look at the details of how they did this, right? But it's an amazing increase in performance. Scaling maintenance effort dropped by 10x. Retired over 300 Oracle hosts just from one major workflow that we retired off of relational database technology. So if you work for a large organization and you are looking at how do I get from point A to point B with relational technologies to NoSQL technologies, and you look at the need to scale, then come talk to us. Talk to AWS Professional Services. Engage my team. We're very familiar with doing this. We've been doing this for our own internal business and for other customers as well. Something that a lot of customers are benefiting from. Migration has never been easier to get into DynamoDB. We have now data migration services to assist in the migration from non-relational databases into DynamoDB, relational databases, other sources, whatnot, be able to transform that data and push it into DynamoDB in a data structure format that actually works, for your applications. And we also have, technical resources and professional resources to work with you on how to transform your schema, right? And to how to work, and how to make it work efficiently with DynamoDB. So always a way to do that, and usually required, right? When you move from a relational database into any non-relational technology, there's some restructuring of that data that must occur. You can use data migration services to help with that ETL. You might need some professional services, to help with the actual design and for that transformation. So we're here for both. DMS usage is now free for 6 months. Some information on the Amazon site for you: aws.amazon.com/DMS/free-DMS. Go take a look and see if the service helps you. DynamoDB and serverless technology is really, these things are married at the hip, right? So if you're familiar with AWS, we've been pushing the idea of serverless infrastructure. You push your code up into the cloud and let the code run when the code needs to run. And really what this means is you need backplane services, right? You need the compute services, you need storage services, and you need database services that are always online, but they're not tied to dedicated physical infrastructure. So DynamoDB is a really good platform for that. It is a backplane service. It's what we call a tier 0 service at AWS. As a matter of fact, nothing runs at AWS without DynamoDB. Every single service we have stands up on top of it. Therefore, when we deploy a new region, DynamoDB is one of the first, if not the first, service that has to come online before anything else can. But it is a core component of the serverless framework. And if you talk about, again, some of the things that people do with Dynamo and the ability to perform on demand and elastic, it's, you get down to big events, right? Big events like the World Series, when the Cubs won the World Series, and you look at services like Snapchat, right? Snapchat's DB writes per peak, peaked out at over 3 million. 11 million requests, or 3.7 million WCUs after the Cubs actually won the World Series. So an amazing spike. And if you look at the performance graph of the service, the ability of the service to scale dynamically to meet that requirement, and this is like going into the peak, but all the way up across the peak, you saw multiple peaks, and DynamoDB was auto-scaling all the way up to meet that 3.7 million requests per second at the peak of that World Series win. So again, amazing performance tied to real-world events, the ability to scale in real time, and proven again and again and again through these types of events. Amazon's Thursday Night Football performance was another example. We had over 300,000 plus concurrent video players hitting the service simultaneously whenever we saw an ad break, looking for ad pod configurations and whatnot. The ability of the service to dynamically scale to support that load. I mean, the initial on the Thursday Night Football kickoff, the initial load that came in was on almost twice what was forecast. And we were able to scale the DynamoDB partitions on the table, double the number of partitions on the table in seconds to meet the burst capacity requirements. So literally the first ad break, we saw throttling on the table. Second ad break, no throttling on the table. And in between, we're able to split those partitions and be able to double the burst throughput of that table. So you can't do that with a physical hosted solution, a self-managed solution, right? You just can't. If you're out of capacity, you are out of capacity, and it could take you a month to get more. Nice thing with managed services like DynamoDB is that dial it up, dial it down capability. Gives you a lot of flexibility. Prime Day. Another perfect example of the ability to scale the system. Again, we have one service on Prime Day at Amazon. I was in the Prime Day war room when this happened, and the U.S. Prime Day kicked off, and all of a sudden we saw a huge throttling on what we call there's a main box on our website that contains all the deals that are current. Well, that deal that was throttling, and that's stopping orders, right? So again, forecast load that exceeded that was well under the reality. We needed to increase capacity on the table. We tripled the throughput for the tables of that service, and we did it in under 15 minutes in 2 stages. Again, you just don't get that kind of performance, that elasticity. It's impossible to get from fixed infrastructure. It's just no way you can do it. So having the ability to dynamically turn those dials just gives you an amazing amount of flexibility as a customer. At the peak on Prime Day, DynamoDB was delivering over 12.9 million requests per second just for CDO tables, right? Amazon Commercial, Digital, and Other. That's what we call the Amazon Retail development organization. Okay, closing thought. Let's talk a little bit about some of the things you can do, right? I mean, what could you do as a customer if you did not have to patch, rebuild servers, manage your backups and restores, deal with high availability configurations, monitoring, ITSM, responding to service infrastructure failures, and dedicating those resources, dealing with performance tuning and in-memory caching and all of the things that come into capacity planning, host provisioning. I mean, think about the infrastructure lifecycle and the supply chain that you have to maintain to be able to deal with your own capacity planning and provisioning and repair and retirement and lifecycle management for that infrastructure. What are all the other things you can do if you actually just let DynamoDB do all of this stuff for you? And my theory is you can actually do one heck of a lot. I've seen a lot of customers, as a matter of fact, that have been able to free up huge chunks of infrastructure and deprovision that infrastructure and free up enormous amounts of resources to work on features that matter for their customers.
All right, that's what we have for today. So thanks everybody for joining us for this discussion. Feel free to ask some questions. We have some great people here to field those questions, including myself. So with that, let's go into the Q&A.